work through our Unit 4, Lesson 13 skills and notes. This is the first lesson in this new unit, and it's on radicals. So one of the biggest things when we do radicals and understanding radicals is understanding and knowing your perfect squares, or if it's to a third power like a cube root, knowing your perfect cubes. So this chart is just something you really want to commit to memory. The more of these perfect squares that you know, then the easier it's going to be to do this work. And obviously you should know them both ways. So know 5 squared is 25, but also that the square root of 25 is 5. That'll help you with your simplification. Okay, so in this first lesson in this unit, lesson 13, for the year, we're working on just simplifying, and specifically simplifying with square roots. So I'm going to take some time here and go through each of the skills. So let's start with some of the vocabulary. So the radical sign. So when we see this symbol right here, a lot of people often just say square root, but technically this is called a radical symbol, and it is only referred to or written as a square root when there's no number on the outside, which would indicate that the root or the index is a 2. Okay, so when there's no number written out on the outside here for the index, it's implied to be a 2. So therefore this radical with no number here would be the same as writing the radical if you had the 2 for the index. Okay, and you can also see it with an index of 3 or an index of 4, or for that matter with any index. And that number written there is called the root or index. Okay, so then the radicand. So the radicand is the number under the radical sign. So here you see the square root of 5. So the 5 is the radicand. Now in any scenario, whatever is inside the radical is the radicand. So it could be a number, it could be variables, it could be both. So for instance here, the radicand would be 3x. Okay, the radical includes the radical sign, the root index, and the radicand. So we would say this as the square root of 3x, and that's the whole radical. Alright, and what we're going to be working on today is the simplified form. So how do we create that simplified form, and what does that look like? So a square root is simplified when the number under the square root has no factors that are perfect squares, and a cube root is simplified when the number under the cube root has no factors that are perfect cubes. So for instance here you see the square root of 50. Well, we'd simplify that into 5 square root of 2. And here you see the cube root of 24, which would simplify into 2 cube root of 3. Okay? And what we're really working on here today is being able to do this process, going from the not simplified to the simplified. Okay, so let's look at an example here with just integers, so no variables here at all yet. So here we see simplify the square root of 72. Okay, so when we're going to look to simplify the square root of 72, we want to split the radicand, which again remember is that number here under the square root, up into a perfect square times another number. And specifically you want it to be the biggest perfect square. So there would be other perfect squares here that you could do. For instance, you could do 9 times 8. However, we'll see in just a second and I'll show, this is going to result in more work. Okay, and a secondary set of steps that we'd like to avoid. So instead, if I went here, square root of 36 times square root of 2, we're going to break that up or split up the square root. So once I get 36 times 2 to give me 72, I can write that as the square root of 36 times the square root of 2. And then, if I know my chart from back here, well, what is the square root of 36? Oh, it's 6. So therefore, I can just rewrite the 6 instead of the square root of 36. And then the square root of 2 is not a perfect square, so that would stay. So my final answer would be 6 square root of 2. Now in this method, which is okay because the square root of 9 is a perfect square, the square root of 9 is 3, so that would be written on the outside as my coefficient, and the 8 would stay on the inside. However, the difference here is we're not done, because I could still break down the 8 into 4 times 2, and the square root of 4 is a perfect square. The square root of 4 is 2. So we get 3 times 2 square root of 2. And then you'd have to do 3 times 2. Well, 3 times 2 is 6 square root of 2. Now, notice what I just circled here in purple is the same thing as what I got up here. However, this really took us breaking it down not once, but twice. Here we only had to break it down one time. So we're always going to look to take out that perfect square that's the biggest perfect square when there's more than one. Okay, over here on the other side, let's try that process again. So I need to simplify the square root of 80. Okay, if I'm going to simplify the square root of 80, I need the biggest perfect square to break down 80. So first I'll show you this if I just know it in my head, and then I'll show you how to use the Desmos calculator to find it if you don't know otherwise. So the biggest perfect square that can divide evenly into 80 would be 16, because 16 times 5 gives me 80. So then I can split that up into square root of 16 times square root of 5. And now from here, well, the square root of 16 is 4. And then I bring down my square root of 5. And then that would be my answer, 4 square root of 5. Okay, now what if you can't come up with these numbers? So like you just don't know these perfect squares well enough, or maybe you know the perfect squares. If I just say, you know, what's 6 squared? You can say 36, but it's hard for you to realize that's what you should do to get to 72 to come up with those factors. Well, now let me show you what that looks like in Desmos. So for square root of 80, I'm going to go in here, and what I'm going to do is I'm going to set up division. So I'm going to go 80 divided by, okay, and now what I'm going to do is I'm going to divide by the biggest perfect square that's less than 80. So 81 is bigger than 80, so I'll start with 64, and I'm going to work my way down until when I divide, I get a whole number, meaning no decimal, right? So 80 divided by 64, we should know that's going to be a decimal, so that doesn't work. So now I'm going to keep working down. 49, that's a decimal. 36, decimal. 25, decimal. 16. Notice how now I get a 5. That's what we're looking for. So now you'd say, oh, 16 times 5. And then that would give you those numbers that I just used. So if you need to, you can use that Desmos help, at least short term, to learn how to get to these quicker. Okay, that's what it looks like when we're simplifying with just an integer, so a number with no variables. So now let's break it down with variables. So when I'm going to simplify the square root of x to the 5th, remember this is like the index is a 2. It's an implied 2 right here. So square root of x to the 5th is the same as the square root of x to the 5th. Since the index is 2, we're going to rewrite the variables using exponents of 2. So make sure you don't change the value of the radicand. So in that case, that would be like x to the 2nd times x to the 2nd times x. Well, if I break these down, okay, into sets, again, I'm trying to come up with sets of 2. So 2 and 2, and then a 1, okay? Well, the square root of x squared is just x. They cancel each other out. So 2 goes into 2 one time, so I get x. 2 goes into 2 one time, so I get x. And then the square root of x, because I had 1 left over, gets brought down. Well, now as we should know from Algebra 1, x times x, when I'm asked to multiply with exponents, I actually add them. So x times x is x squared. I bring the square root of x down. So here's my simplifying. Now if you want it in a different way, here's another way to think about it. Remember, this is an implied 2. So how many times can 2 divide into 5, right? Because x to the 5th really means x times itself 5 times. Well, we want how many sets of 2 do we have? We have 1 set of 2, 2 sets of 2. So 2 sets of 2, so that's where the x squared comes from on the outside, with 1 left over. That's why we have 1 left on the inside. So here, when I'm asked to simplify x to the square root of x to the 6th, how many sets of 2 can I make? Well, we should know 2 goes into 6 3 times, but just to show the visual, I'm going to write out x times x 6 times. When I do that, then I need how many sets of 2? Well, 1 set of 2, 2 sets of 2, 3 sets of 2. No remainder. So that's why I would just get x to the 3rd here with no remainder. Now to show it out in this method, I'd break it down into sets of x squared. So here we go, x squared, x squared, and x squared. And the square root of x squared is x, so we get x times x times x. Remember, when we're asked to multiply with exponents, we actually add them, so 1 and 1 and 1 gives us x to the 3rd. Okay, hope this video helped for going through lesson 13, simplifying square root radicals.